Hello everyone, I Abhishek Misal welcome you to on the lecture of binary coding and data transmission pulse modulation. This topic is from the course of Fundamental of Communication System and its application. Today we continue on a fascinating journey into the world of digital communication. In the previous lecture, you study about sampling theorem and PPM, pulse position modulation, pulse amplitude modulation and pulse width modulation. In that lecture, we cover the definition of sampling, sampling reconstruction, sampling signal, the quantization, pulse amplitude modulation, pulse width modulation, pulse position modulation. Now, we cover the digital era, efficient data transmission and encoding are crucial various communication systems. The process involves converting information into a digital format, transmitting it over a communication channel and then decoding it back into its original form. This lecture will cover the fundamental of binary coding and data transmission in digital communication, emphasize key concept, technique and practical application. Binary coding and data transmission are fundamental concepts that ensure data is sent and received accurately and efficiently. Pulse modulation is the method used to digitally represent analog signal, facilitating their transmission over digital communication system. This lecture will explore binary coding, data transmission and different aspect of pulse coding modulation. Now, we first discuss binary coding. Binary coding is the foundation of digital communication. It involves representing information using binary digit, typically 0 and 1. This system is favored due to its simplicity and reliability in electronic circuit. Now, we discuss binary number system. Here, the definition of binary number system. The binary number system is a base 2 numeral system, unlike the decimal system which is base 10. It uses only 2-digit 0 and 1, known as bit conversion. Decimal to binary convert a decimal number to binary number by repeatedly dividing the number by 2 and recording the remainder. Binary to decimal conversion. Convert a binary number to decimal by multiplying each bit by 2, raising the power of its position and summing result. Binary coding scheme. Binary coding scheme are used to represent different type of data in a digital format. ASCII. ASCII is American Standard Code for Information Interchange, a character encoding standard that use 7 or 8 bit to represent text character. Unicode, an extended character set that support a wide range of character from different language using up to 32 bit. BCD, binary code decimal, encode each decimal digit as a separate 4-bit binary number. Advantage of binary coding. Simplicity. Binary coding is a straightforward and easy to implement in electronic circuit. Reliable. Digital systems are less susceptible to noise and interference compared to analog system. Scalability. Binary coding support various data type and can be scaled to represent complex information. Data transmission. Data transmission refer to the process of sending data from one point to another. It involves several key concepts and methods to ensure the integrity and efficiency of communication. Transmission mode simplex. Data flow in one direction only, that is keyboard to computer. Half duplex. Data flow in both directions but not simultaneously. For example, walkie-talkie. Full duplex. Data flow in both directions simultaneously. For example, telephone call, mobile communication, etc. Now we discuss the transmission media. The medium through which data is transmitted can either wired or wireless. Wire include twisted pair cable, coaxial cable and fiber optic. Wireless utilize electromagnetic waves including radio waves, microwave and infrared. Error detection and correction. To ensure data integrity, various error detection and correction techniques are employed. Parity bit. Add an extra bit to data to make the number of ones either even in the bracket even parity or odd parity. Checksum. Sum the data segment and transmit the total along with data to detect error. Cyclic redundancy check, that is called CRC. Use polynomial division to detect error in transmitted data. The another type of coding method is Hamming code. Detect the correct single bit error by adding redundant bit to the bit. Digital modulation technique. Digital modulation involves varying a carrier signal to encoded digital information for transmission. Common digital modulation techniques includes amplitude shifting, modulate the amplitude of carrier signal to represent binary data. Frequency shift key FSK modulates the frequency of the carrier signal to represent binary data. Phase shift key PSK modulates the phase of the carrier signal to represent binary data. Quadrature amplitude modulation, that is called QAM, combine amplitude and phase modulation to represent multiple bits per symbol. Now we discuss the pulse code modulation. Here with the introduction of pulse code modulation. Pulse code modulation is the process of varying one or more parameter of a carrier signal in accordance with the instantaneous value of message signal. The message signal contains the information to be transmitted, while carrier signal is a high frequency signal with no inherent data used to facilitate long distance transmission. Various modulation techniques exist and pulse code modulation, that is called PCM, is widely used digital modulation technique. PCM converts analog information into a binary sequence in the form of 1 and 0, resulting in an output that resembles a binary sequence rather than a continuous pulse train. In PCM, each binary digit represents the approximate amplitude of the signal at that instant. Basic element of pulse code modulation. The pulse code modulation system consists of two main sections. First, the transmitter and second, the receiver. Each section have several key components which are explained below along with the block diagram. In the block diagram of pulse code modulation, the figure show that in this figure the basic element of PCM transmitter and receiver section you saw that. The transmitter section of pulse code system include the following component. The first component is low pass filter, which is shortly called LPF. Then next is sampler, then third is quantizer, then encoder. Now let's discuss the first component, that is low pass filter. The low pass filter eliminate high frequency component from the input analog signal that are higher than highest frequency of the message signal. This prevent aliasing, which can distort the message signal during the sampling process. The next component is sampler. The sampler collect instantaneous value of the message signal at regular interval. According to the Nyquist sampling theorem, the sampling rate must be greater than twice the highest frequency component of message signal to ensure accurate reconstruction of original signal. Here the equation is Fs is greater than 2Fm, where Fs is the sampling rate and Fm is the maximum frequency of message signal. The another important part is quantizer. Quantization involves mapping the continuous amplitude value of sample signal to a finite set of discrete levels. This process reduces excessive bits and compress the data by assigning each sample a specific quantized value, introducing quantization noise as a trade-off. Now we discuss the encoder. Encoder convert the quantized value into binary code, effectively digitalize the analog signal, Each quantized level is represented by a unique binary sequence. The combination of the low pass filter, sampler and quantizer act as an analog to digital converter, that is ADC, while encoding minimize the bandwidth required for transmission. Now we move on to the receiver section. The receiver section of a pulse code modulation system includes the following component. First, regenerative repeater, decoder, reconstruction filter, regenerative repeater. The regenerative repeater amplify the received signal, compensating for signal loss, and reconstruction the original signal strength. This helps to maintain signal integrity over a long distance. Then decoder. The decoder converts the pulse code binary sequence back into the original analog signal. This demodulation process involves reversing the encoding step performed at the transmitter. Now we discuss the another important part is reconstruction filter. After digital to analog conversion by the regenerative repeater and decoder, the reconstruction filter, which is a low pass filter, is used to remove high frequency component and retrieve the original analog signal. The advantage of pulse code modulation, it is noise immunity. Pulse code modulation signals are less susceptible to noise and interference compared to analog signal. And the next advantage is efficient transmission. Digital signal can be easily compressed and multiplexed. Consistently, PCM provide uniform signal quality and reliability. Here we discuss some application of PCM. PCM is widely used in various applications, includes telecommunication, digital telephony, voice over IP communication and other communication systems. Use PCM to digitalize and transmit voice signal. Audio recording. PCM is the standard method for encoding audio on CD, DVD, and digital audio broadcasting. Video broadcasting (PCM) is used to digitalize and transmit video signal in digital television and streaming service. Now we discuss the practical implementation of PCM. Implementation of PCM involves several steps from signal sampling to quantization and encoding. Let's explore these steps in detail. Now, the first step is signal sampling. The first step is to sample the analog signal at a rate that satisfies the Nyquist criteria. The sample values are stored in an array for further processing. Quantization. The sample value are quantized in discrete level. This step can be implemented using quantizer function that maps the sample value to the nearest quantization level. It is very important and it is very much significant process in the pulse code modulation. Then encoding. The quantized value are then encoded into the binary format. Each quantized value is converted to a binary coding using a predefined encoding system, which is discussed in this lecture about the Hamming code and checksum code, etc. Now, digital transmission. The encoded binary data is transmitted over a digital communication channel. This can involve various modulation techniques to ensure efficient and reliable transmission. Then error detection and correction in PCM. To ensure accurate data transmission, PCM system can use error detection and correction technique. These techniques help identify the correct error that may occur during transmission. The next is parity bit. A parity bit is an extra bit added to data set to make the number of ones either even or odd. It helps to detect single bit error. This type of method are used. Another method is checksum. The second is cyclic redundancy, Hamming code, etc. Now, here we will discuss the pulse code modulations much more detail. For example, pulse code modulation is the technique. Here, the pulse code modulation steps we will discuss. The primary step involve pulse code are sampling, quantization and encoding. These steps are crucial to converting analog signal into digital format, enabling efficient and reliable communication. Now, we are study some another part of pulse code modulator. Here, the pulse code modulator have a receiver. The receiver section is very important in pulse code modulation, and we will much more detailed studies because pulse code modulation is very important. The receiver section of pulse code system perform the reverse operation of the transmitter to reconstruct the original message signal. The components and function of a PCM receiver are as follows. Regenerator. A regenerative repeater at the receiver end reshape the PCM signal, eliminating channel included noise. Another part is digital to analog converter and sampler. A digital to analog converter, that is called DAC, convert the digital signal back into an analog form. The sampler help this conversion process. Now, the low pass filter. As we already study about the low pass filter, but here we will study the mathematical expression. The output of sampler is fed to an low pass filter with cutoff frequency, that is FM. The low pass filter also known as reconstruction filter, produce the original message signal. Transmitting bandwidth in PCM. The transmission bandwidth of a PCM system is related to the number of bits per sample. An increase in the number of bits per sample results in a higher bandwidth requirement to achieve good approximation. A large number of quantization levels are used, leading to increased bandwidth. The number of quantizer level q represented by n binary digit is q is equal to 2 to the power n. The number of bits per sample is n, and the number of samples per second is fs. The number of bits per second is signaling rate, which is r is equal to nfs. The transmission bandwidth Bw is half the signaling rate, and that is Bw is greater than r by 2. Considering fs is greater than 2fn, the bandwidth of a PCM system is Bw is greater than nfm. Here the some advantage is which is already discussed, but some more advantage are this: noise and distortion immunity. PCM signals are less susceptible to noise, and their repetitive regenerative can be used along transmission path to maintain signal integrity. PCM secure the data transmission with the help of encoder to convert the specific code, and the quality is uniform transmission quality. It maintain the signals quality is uniform. PCM ensure consistent signal quality. Some disadvantage are also in the PCM signal. The first is increase the bandwidth. PCM require higher transmission bandwidth. The complexity of PCM system is more than other modulation system. Now, the bandwidth constraint. Here PCM requires significant bandwidth for high quality transmission. Bandwidth constraint can be addressed the data transmission employing compression and algorithm to reduce the amount of data transmitted. Efficient encoding, using more efficient encoding scheme to minimize the number of bits per sample. Now, here we discuss the future trends in PCM. Pulse code modulation consists to involve with advancement aim to improving its efficiency and quality. Some emerging trend includes are the adaptive pulse code modulation. In the adaptive pulse code modulation, dynamically adjust the quantization level and sampling rate based on signal characteristic. This approach optimizes the trade-off between the signal quality and bandwidth required. The next is delta modulation. Delta modulation is simplified form of pulse code modulation that encodes the difference between successive pulse code modulation is a fundamental technique in digital communication that enable the accurate and efficient representation of analog signal in digital format. By understanding the principle of sampling, quantization and encoding, as well as the challenges and solution associated with PCM, we can appreciate its importance in modern communication system. As technology continue to advance, pulse code will continue to play a critical role in ensuring high quality digital communication across various applications and industry. Now, here we discuss the quantization. Quantization, we already know that is the process of mapping continuous amplitude value of sample signal into discrete level. This introduces a quantization this introduced the quantization error, which is the difference between the actual analog value and nearest quantized value. Here we discuss some type of quantization. First type is uniform quantization. The range of signal is divided into equal size interval. Non-uniform quantization. The interval vary in size, often is smaller for lower amplitude and larger for higher amplitude to improve signal to noise ratio. Now let's discuss the quantization error. The quantization error is represented by En is given. Here En is equal to xs in the bracket n ts minus xq in the bracket n ts, where xs is the sample signal and xq in the bracket n ts is quantized signal. Now encoding. Here the encoding is the process to converting the quantized into binary format and suitable for digital communication. There are the different encoding method. The first method is binary encoding. Each quantized level is assigned a unique binary code. The number of bits and required to represent each quantized value depend on the number of quantization level. It will be represented by n is equal to log base 2 in the bracket L. Now in the communication, the another important part is companding. Companding means compressing, companding means compressing and expanding. It is a technique are used to improve the dynamic range of signal. That two common companding technique, that is mu law companding used in North America and Japan. The other technique is A law companding technique used in Europe and other regions. Signal to noise ratio. It is a very important parameter in the communication. The signal to noise ratio is measure the signal quality in a PCM system. It is defined as the ratio of the signal power to the noise power from uniform quantization. The SNR is given by SNR is equal to 6.02 into n plus 1.76 dB, where n is the number of bits per sample. Now next is bandwidth requirement. The bandwidth required for PCM depend on the sampling rate and the number of bits per sample for a maximum frequency FM and n bit per sample. The bandwidth B is equal to NFS is equal to 2 NFM. Here the application of PCM, which is basically used for audio recording, video recording and resolve the non-uniform quantization error. Another application is binary encoding. Represent each quantization level to a binary number. Then we discuss the some mathematical expression which is better to understand the mathematical representation. Pulse code modulation represent the signal in mathematical format, which is very much understand. But in the course of fundamental communication system, you have to understand the block diagram, the basic conditions for communication system. So in the conclusion, here we discuss the binary representation method of signal, where the analog signal is represented by different method like binary representation, ASCII method. Then we learn the transmission process, where we add some parity bit, check some bit for smooth and error free transmission. Then we learn the pulse code modulation. In this method we study the block diagram of pulse code modulation in detail, where the pulse code modulation is divided to the two parts, which is the transmitter and receiver, and in the each component we will study the detail and the mathematical expression of this block diagram. Then we discuss the some advanced pulse code modulation, which are the adaptive pulse code modulation, which will be help the signal, which will be help to remove the error, or the value of error is less. Then another method, which is simple method, is the delta pulse code modulation, which will be much more advanced method, and using for this we can convert the analog signal into digital signal and easily transmit it. Then after we study the applications of pulse code modulation. In this application we understand that the pulse code modulation is used everywhere, in the data storage process, in the communication process, in the transmission process and broadcasting process. Then we study the some disadvantage of this pulse code modulation. The system which have the so much power efficiency have some disadvantage also, that is it require higher bandwidth as compared to other communication system. Then second thing is it require complex electronic circuitry which will be used in the communication. So it is, if the circuit is complex, it is very difficult to maintain, but it will be necessary for communication. So I hope you understand the binary signal representation and pulse code modulation in detail. So I will thank you for your patience, learning and constant continuation I here. So I thank you for your patience, learning and continuous studying this course. I hope you enjoy and detail, and I hope you enjoy and understand the concept of communication. Thank you.